So next is binary arithmetic. So in binary arithmetic, we'll be dealing with addition and subtraction at first. So in addition, binary addition, let's take just 2 bits. Okay, or we'll first deal with 1-bit addition. So in 1-bit addition, suppose you have 1 bit, we are adding 2 1 bits. Okay, so hereafter I'm talking only about binary numbers, so I'm not writing the base 2 to make it simple. So in this binary arithmetic, I'll be dealing only with binary numbers. So base will not be written. So if the 2 bits I'm adding is say 0 and 0, 0 plus 0, this is addition symbol. Okay, so that is 0. 0 plus 1 is as usual 1. 1 plus 0, that will be again 1. But then what is 1 plus 1? 1 plus 1, this one and this one is binary ones, not the decimal one. So when 1 plus 1 is taken, so normally in decimal 1 plus 1 is 2. 1 plus 1, 1 in decimal plus 1 in decimal is equal to 2 in decimal. So what is 2 in binary? 2 in binary is 1 0. So in the case of 1-bit addition, you'll be having 1 bit as the sum. So this is the, this whatever you've written here is the sum, the answer. So what is this 0? Sorry, till here. Okay, that is the sum. And here in the case of 1 plus 1, the answer is 1 0. So this 0 is the sum and this 1 is the carry. Just like in any normal decimal addition, we have a carryover. Just like that, here also you have a carryover, that is this particular one. Okay, suppose you are adding 2 numbers, 5 plus 5, both decimal, you'll be writing 0 1, right? So if it is 15 plus 5, 0, carry over 1. This carryover, that is this one. So why here carryover? Because these are all 1-bit numbers. You are adding 1 bit. So when you are adding 1 bit, you have only a space of 1 bit to store the answer. So whatever answer exceeds that 1 bit, that will be taken as a carry. Okay, so here 5 plus 5. You must have studied in school, like this is the tens place, this is the ones place. So in ones place 5 plus 5 is 10. So you can't write 1 and 0 in the ones place. You have to take the tens place number carried over to the tens place. Just like that, you have only 1 bit space to store the sum in this particular case, because this is 1 bit and this is 1 bit, this is 1 bit, this is, each of them are 1 bits. So you have only 1 bit space to store the sum, and whatever comes in excess will be taken over to the as the carry. So this is 1-bit addition. So in 1-bit addition itself, you can suppose 1 bit addition, you are taking 3 1 bits, suppose. That is 0 plus 0 plus 0, 0 plus 0 plus 1, 0 plus 1 plus 0, 0 plus 1 plus 1, 1 plus 0 plus 0, 1 plus 0 plus 1, 1 plus 1 plus 0, and 1 plus 1 plus 1. All the 8 combinations, 1, 2, 3, 4, 5, 6, 7, 8, all the 8 combinations possible. So all zeros means the answer is 0. 0 plus 0 plus 1 is answer is 1. 0 plus 1 plus 0, answer is 1. 0 plus 1, 1. And 1 plus 1, it is 0 with a carry 1. 1 plus 0 plus 0, it is 1. 1 plus 0 plus 1, 1 plus 1 is 0 with a carry 1. 1 plus 1 is 0 with a carry 1. 1 plus 1 plus 1. So 1 plus 1 is 0 with a carry 1. This plus 1 is 1 with the previous carry. So the answer is 1 with a carry 1. Or you can say that 1 plus 1 plus 1 is 3 and 3 is notated as 1 1. But the actual thing is like this. So here this particular thing, this is called the sum, and this is called the carry. So what is the carry in all the other cases? It is 0. In the other cases, you don't have a carry and the carry is 0. So this is binary addition. Okay. So suppose you are taking, let's take some big numbers. Suppose 12 in decimal plus 8 in decimal. Do the addition using binary addition. Okay. Add 12 in decimal and 8 in decimal using binary arithmetic. So if that is the question, then first you have to write 12 in binary, 8 in binary. So when you write this, normally what you do is, whichever is the greater number, you will write it using the number of bits required to write the greatest number of the two. So in this case, anyway, you need 4 bits for both. But if suppose this is 1, this is 1, then you'll write 1 also using 4 bits, just as you would in 12. So 12, as you know, is 1100 using the 8421 code, plus 8. 8 is 1000. So you should know the binary of everything by heart. So only then we will be able to write it fast. So 0 plus 0 is 0. 0 plus 0 is 0. 1 plus 0 is 1. And 1 plus 1 is 0 with a carry 1. Okay. So this is your answer. Now what is this? You have to check whether the answer is correct or not. Okay. So here this is 2 raised to 0. Weight is 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3 and 2 raised to 4. So this will be 1 into 2 raised to 4 plus 1 into 2 raised to 2. That is 16 plus 4. That is 20 to the base 10. So hence root. So that is how you do the addition. We can consider another case, say with 3 numbers. Let's take 15 plus 16 plus say 8, or I'll take a smaller number, say 3. Okay, so 15 is 1 1 1 1, 16 is, so here you need only 4 ones. Here you need a 5th bit. So what I'll do is I'll put a 0 here. Okay, so that all the numbers have the same number of bits. Even otherwise, for addition it's okay, only for subtraction that will make a difference, but then it's better to write like this so that you don't go wrong. And 3 is actually 1 1, so I'll just append zeros to the left. So 1 plus 0 plus 1 is 0 with a carry 1. 1 plus 1 is 0 with a carry 1. That plus 1 is, that is 3 ones is 1 with a carry 1. 1 plus 1 is 0 with a carry 1. 1 plus 1 is 0 with a carry 1. 1 plus 1 is 0 with a carry. So here the actual answer is 33, sorry, 31, 30, 34, right? 34 to the base 10. And here you can see that it is 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5. So the answer is 1 into 2 raised to 5 plus 1 into 2 raised to 1, that is 32, plus 2, that is 34. So you have proved that the answer is correct. This much is the answer. You need to do only till here, but then you can, it's always good to cross check and see whether the answer is correct or not, because you can make mistakes. Okay, so this is your answer. So your answer will be 10010 to the base 2. If you are told to do using binary arithmetic, then you have to do like this. Okay, so that is addition. So next is signed numbers. That is to study about binary subtraction, you need to know how to represent a signed number. So what do you mean by a signed number? Anything with a sign is a signed number. So what are the two signs you know? It is positive and negative. A number is either positive or negative. So how do you represent a positive number and how do you represent a negative number? Now, what is the significance of knowing how to represent a signed number? Because suppose you want to subtract, say, 4 minus 5, both in decimal. 4 minus 5 you want to subtract. So your answer is minus 1. Minus 1 to the base 10. Okay, so here the answer is negative. So how do we know that the answer is negative and not just 1? We need this sign. So for that, in the case of subtraction, you need to know whether the number is signed or not. So this is a bit confusing for many. So, but it's very easy. You just need to know some basic rules. That is, in order to represent a signed number, there are different methods. One is, and the most easiest one is the sign magnitude form. sign magnitude form. So just as the name suggests, it is sign followed by the magnitude. So suppose you have a number, say plus 5. Okay, so just like the name, you have a sign bit and then the magnitude. So for plus 5, magnitude is what? 101. 101 is the 5, is 5. So you also need sign. This is just the magnitude. This is the magnitude. So you need the sign. For sign, you put a 0 here if it is positive. And if it is negative, you put a 1. Positive, 0. So the sign bit is the bit to the left of MSB. Okay, MSB is normally set for binary. This is not actually binary. It's a form of binary representation with sign. So you have, this is the magnitude. So MSB, LSB will be these. To the left of this MSB, you will have a sign bit. And sign bit, if it's 0, then that number is positive. If it's 1, then the number is negative for any signed number representation. Not only in the case of sign magnitude form. So when you write and when you get confused, just see whether the sign bit is 0 or 1 and what your answer should be. Is it a positive number or a negative number? So if it's a positive number you need, then the sign bit will be 0. If it's a negative number, then it should be 1. If that you've got wrong, then your procedure has gone wrong somewhere. Okay. So what is then minus 5? So minus 5, again 5 is 101 and minus 5 means the sign bit will be 1. So this is in the sign magnitude form. Don't write to the base 2. Okay, when you write it as to the base 2, that means it's a binary number. This is in the sign magnitude form, in sign magnitude form or in any signed number representation. Do not write the base. Do not write base in the case of signed numbers. Okay, so if you write to the base 2, then it means it is 13. It's not minus 5. But then if you write it like this and say that this is in the sign magnitude form, then you know that the leftmost bit, this is the sign, so it is negative, and this is the magnitude, 101 is 5. This is in binary. This particular portion is, the magnitude is in binary, this is the sign. Okay, but then don't write base here also. Do not write base anywhere in the case of signed numbers. So that is one form of sign number representation. Now another method, second method is ones complement. Ones complement form. Okay, now what is ones complement form? Ones complement form is complement each bit. Complement each bit. So I'll explain with an example. Say you have plus 4 and minus 4. We'll write the ones complement of both the positive and the negative number. So we know that in a sign number representation, you will always have a sign bit, which is the leftmost bit. Okay, so in the case of plus 4, the leftmost bit will be 0 since it is positive number. Now 4 is 100. So this is the signed number representation of plus 4. In the case of positive number, the ones complement form is same as the ones complement sign magnitude and twos complement, which will be the next portion. All representations, the number will be same as the binary number, but the leftmost bit should be a 0. If the normally written binary number for that particular number has a 1 at the MSB, then just append a 0 to the left. That is 4 is actually 100 to the base 2. But you can't write like this. In the case of sign number representation or ones complement form, it is 0100 because you need a sign bit. And don't put the base. So it's both the same, just put a 0 there to make it positive. But in the case of negative number, first write the positive numbers representation in the sign magnitude form, or okay. So 0100. Then complement each bit. Complement each bit means what? If it's 0, make it to 1. If it's 1, make it to 0. So this becomes 1, 0, 1, 1. This is your ones complement form of -4. So ones complement form of +4 is 0, 1, 0, 0 and -4 is 1, 0, 1, 1. So how do you know that one is positive and one is negative? Suppose I am given a number in zeros and ones, and I say that it is in the ones complement form. Okay, suppose I am given, say, 0, 1, 0, 0, 0. This is the number. This is in the ones complement form. This is what I have been told. So we'll first check what is the leftmost bit, that is the sign bit. Sign bit is 0, so it is positive. Then since it is positive, this will be same as the binary number. You won't be complementing it. So this is +8. Okay, suppose I am given, say, this is the number I have been given, and I am told that this is a this is represented in the ones complement form. So what I'll do is, the question was this. So this is 1, so it is a negative number. And since this is a negative number, the answer is in the complemented form. So I'll have to complement it once to know the actual number. So what is the actual number? It is -0011. That is 3. That is, the answer is actually -3. Okay, that's how you find out what the value of the decimal value of a particular signed magnitude or ones complement form of a number is. So that is the sign magnitude form and the ones complement form. Now the last one and the most popular one which we will use in the subtraction is the twos complement form. So the question is 4 minus 2. You have to do this using binary subtraction. So for that, we need to know the 2's complement form. Okay, so for any binary subtraction which we will be dealing with, we'll be using the 2's complement form. So in 2's complement form, how to find the 2's complement form? We'll discuss that and then come to the subtraction. So I told that plus 4 in 1's complement form is 0, 1, 0, 0. And in sign magnitude form also it is 0, 1, 0, 0. In 2's complement form also it is 0, 1, 0, 0 itself. So 0, 1, 0, 0 is the same representation of plus 4 in any representation. Whatever be the representation type, it is 0, 1, 0, 0. For any positive number, it is sign followed by the magnitude. 1's complement, 2's complement or sign magnitude form, the representation is the same. So positive number is just the binary number appended with the 0 to the left. Now what is minus 4? In order to find the value of 2's complement of minus 4, there's a small procedure, that is, say here first we'll write the positive number 0, 1, 0, 0. Then we'll take the, to find minus 4. Then take the 1's complement. So 1's complement is what? All the bits are complemented. 1, 0, 1, 1. And to find the 2's complement, add 1 to the 1's complement form. So 1 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. 0 plus 1 is 1 and 1. So this is the 2's complement form of minus 4. So if you want to find the 2's complement form of any negative number, first write the 2's complement form of its positive number. Then complement each bit. Then add 1 to the answer. So the procedure is to find the 2's complement of any negative number. Only in the case of negative number, not in the case of positive number. Positive number, it is same as the sign magnitude form with sign as 0. So 2's complement form, in order to find it out, first write the write the positive number with 0 as the sign. Okay, positive number 100 with 0 as the sign. Then write the complement, that is, complement each bit of this particular number. This particular number, complement each bit. Last step is to the, this will give you the 1's complement. Add 1 to 1's complement. That will give you the 2's complement of that particular negative number. So this is the procedure, and this you should know, and many make mistakes in this particular portion. Okay. So do not get confused. For positive number, it is 0 followed by the magnitude. For negative number, you can represent it in sign magnitude form, that is 1 followed by the magnitude, or 1's complement form, that is the positive number with a 0 sign, complement each bit, and 2's complement form, add 1 to the 1's complement form. That is the 2's complement form of a negative number. We will take one more example. Suppose you want to find the 2's complement of say -6. So first step is write plus 6 with a 0 as the sign. So it is 0 and 6. 6 is what? 1, 1, 0. So that is plus 6. Then second step is 1's complement. 1's complement of, that is complement each bit of this positive representation, complement each bit of the positive representation. So 0 becomes 1, 1 becomes 0, 1 becomes 0, and 0 becomes 1. Then to find the 2's complement, add 1 to the 1's complement representation. That is the third step. So 1 plus 1 is 0, carry 1, that is 1, 0 and 1. So that is 1, 0, 1, 0. So the 1, 0, 1, 0 is the 2's complement form of -6.